Hello everyone, welcome back to my channel. So in today's video we'll be discussing about Kruskals algorithm, and we'll be using this algorithm to find our minimum spanning tree for the given graph. Now what is a minimum spanning tree? So basically a graph can have many spanning trees, okay? But the minimum spanning tree is the one whose total edge weight will be minimum. What do you mean by total edge weight? That is when you get the spanning tree, if you calculate all these separate edges, that is 7, 8, 3, 3. If you add all these separate edges and whatever the edge that you're going to get, that should be minimum. Only then your spanning tree is going to become a minimum spanning tree. Now, as you can see, I have a graph over here. Now, the first step to find the minimum spanning tree for your given graph is you need to remove all the loops that are present in the graph. If you see here, we have a loop over here, right? A self loop kind of thing. So the first step is you need to remove all of these loops. This should not be considered while forming your minimum spanning tree. So I'll be removing this loop. Okay, this step is done. The next thing is, in case you have any parallel edges in your graph. For example, in this case you have parallel edges, that is 10 and 15. That is the edge which is going connecting the nodes B and D. There are two edges and those two are parallel to each other. So you are supposed to remove one of these edges. Now the which edge are you going to remove over here is the main question. So you can see one edge is having a cost of 10 and the other edge is having a cost of 5. So you're supposed to remove the edge that is having a higher cost. That is, in this case 10 is the edge which is having a higher cost because 10 is greater than 5, right? So I'm supposed to remove the edge that is having a higher cost. So I'll remove the upper edge which was having a cost of 10. So now my graph is perfect. It doesn't have any loops and it doesn't have any parallel edges. So now I'll find the minimum spanning tree for this given graph. So the first step is I'm supposed to arrange all the edges in the increasing order of their cost. Now what do I mean? Now if you see the edge that is connecting the nodes A and B, the cost for this edge is 7. If you see the edge that is connecting C and E, the cost of this edge is 3. So like this, I'm supposed to consider all the edges and their cost, and I'm supposed to write these edges in the increasing order of their cost. Okay, so I hope you're understanding. So if you see all the cost which is present on the screen, 2 is the minimum cost. That is, 2 is the smallest number out of all the other numbers or all the other cost that is present. So first I will be writing the edges that is having the cost 2. So you can see here we have two edges, that is EF and DE. So I'm supposed to mention these two edges first with the cost 2. Now I can either write DE first or I can write EF first. It is your choice. Anything you can write first. So I'm writing DE first and then I'm writing EF second with the cost value as 2. So you can write it at any order, it doesn't matter because after all the cost value is same, that is 2. Now what is the next cost value in the increasing order? 3. 3 is the next cost value which is present in our graph, and 3 is present for edges C to E and edges B to C, right? So let me mention these edges. So I'll write CB has a cost 3 and CE has got a cost 3. Okay, so now my cost part is done. I have entered 2 and 3 cost. Now what is the next cost value? We have 4. 4 is the next higher cost value in the increasing order, and that is present for which edge? For edge DF. So I'll write DF is equal to 4. Now the next number is 5. 5 is for edge BD. So I'll write BD, edge is having a cost 5. The next higher edge is 6. 6 is for CD. So edge CD is going to have a cost 6. The next number is 7. It is for edge AB. So AB is having a value 7, and then the largest one is of edge AC where the cost is 8. So now if you can see, I have covered all the edges with their cost values in the increasing order from 2 to 8, right? So my first step is done. I have got the list of edges. Now I'm supposed to connect these edges and put them on my minimum spanning tree formation. So that's how you'll get a minimum spanning tree. But while you're forming, you should make sure that you don't get a cycle. Now, what do I mean by cycle? We'll see that now. So the first edge you can see here is DE. So first let me connect DE. Now when I'm trying to connect, I'll try to connect it in this format or in this kind of shape only so that you don't get confused. So first edge DE will come. So here we have D and here we have E with their edge value 2. Okay, so my first edge DE is done. Second edge is EF, which I have to cover. Now where is EF? It was connected like this, right? So I'll connect it in that manner only. I'm connecting it in that shape only so that we don't get confused. If I connect it in any known shape, then the minimum spanning tree is not going to turn out very nice. So in order to avoid any confusion, let us go by the shape of our actual graph. So EF is covered. Next edge is CB. CB is like this. C and B with the value 3. Okay, CB is done. Now the next edge is CE and the value was 3. So CE is also done. Next edge is DF. Now here comes the main question. If I connect this D to F, what happens is if I connect D to F, I get a cycle, that is D, E and F. Cycle, if you're not able to understand, think of it like a closed loop. If I'm connecting D to F, I'm getting a closed loop over here, right? That is D, E and F forms a closed loop. That is, it is forming a cycle. So when there is a formation of cycle because of a certain edge, you're not supposed to consider that edge. Okay, so you will eliminate that edge and you will not consider it in your minimum spanning tree. So we are not going to consider DF in our minimum spanning tree formation. The next edge is BD. Now if you see here again, if I connect BD like this, I will be getting a graph. That is a cycle. That is B, C, E and D. Again it is like a closed loop. Again I'm not going to consider this edge BD because it is forming a cycle over here. So I won't consider HBD. The next edge is CD. If I connect CD like this, I will again be getting a cycle that is in the form of CD and E. So again I have to eliminate this edge CD and not connect it for our minimum spanning tree formation. So that edge is also eliminated. Next edge is AB. So AB I can connect because it doesn't lead to the formation of any of the cycles and the value of AB is 7. The next edge is AC. Now again if I connect AC like this, it is forming a cycle. So I will eliminate the edge AC and not consider it for my formation. So you can see here what this thing which is present over here is our minimum spanning tree. Okay, so we have got our minimum spanning tree over here. Now there are certain rules for this minimum spanning tree. Now what are those rules? So the first thing is you can write this graph as G of V comma E, where V is the total number of vertices and E is the total number of edges. And for this minimum spanning tree, you can consider it as like G dash, which is of V dash and E dash, where V dash is the total number of vertices of your minimum spanning tree and E dash is the total number of edges of your minimum spanning tree. So the rules are, the first rule is your V and your V dash should be equal. That is, the total number of vertices in your minimum spanning tree and that of your graph should be equal. So let me count the vertices in your graph. That is 1, 2, 3, 4, 5 and 6. So there are 6 vertices in graph. In minimum spanning tree, 1, 2, 3, 4, 5, 6. Again we have 6 vertices in our minimum spanning tree. So the first condition is verified. Second rule is that your now total number of edges in your minimum spanning tree is always a subset of the total edges in your main graph. And there is a formula to find it, that is the total number of edges in your minimum spanning tree is equal to the total number of vertices of your graph minus 1. So how many vertices were there in our graph? We just now counted. There were 6 vertices. So 6 minus 1, 5. So if you count the number of edges in your minimum spanning tree, there will be a total edges of 5. So if you see here, this is the first edge, second, third, fourth and fifth. So you can see here we have 5 edges in our minimum spanning tree. So you can check these two conditions and verify whether your minimum spanning tree is correct or not. So with this, we are done with our Kruskals algorithm. And if you guys still have any doubts left, then you can put that all in my comment section. I'll be reaching out to all of your doubts. So thank you for watching and meet you in my next video.